Hello students, this is the Varchana Raut, lecturer in computer science. In our this slide, we will be discussing about the topic display, power supply and what is bias. So we already know something about display. Display is the output surface in which whatever we give input, we can see the result or we can see the output there. We see display screens on TV, on laptops. So in the coming slides, we will be discussing about the types of display and from where we get the power supply and how the display is been managed, what are the different types of display and their working principle and so on. So let's start. So at the very first step, we will learn what is display. A display is a computer output surface and projecting mechanism that shows text and often graphic images to the computer user by using some of the types. Those types include CRT display, that is cathode ray tube display, liquid crystal display, that is LCD display, or LED display, which is light emitting diode display. Also, there is gas plasma or other image projection technologies too. In this slide, we will be covering about three basic types of display, that is CRT, LCD and LED. The video and graphic informations are generated by a connected computer through the computer's video card. The video card is already pre-installed in the computer's motherboard. This video card is basically managed by the north bridge of the motherboard or north bridge of the chipset. The video card is in the circuit board is attached to the motherboard that connects memory and other necessary circuitry to send information to monitor for display on the screen. Next, we will move to the types of computer displays. There are three types of computer displays. The CRT monitor. These are big and heavy and use a lot of space and electricity. It is the oldest technology used by monitors and is based on the cathode ray tube technology that was developed for basically the televisions. Monitors are made with better parts which give a higher display resolution and picture in case of CRT monitors. The pictures sharpness are much better than the other display technologies. But this type of monitors are no longer popular because of its larger size and higher electricity consumptions. The next type of display we will be discussing is the LCD monitor display. It is the most common type of flat panel display. It is a newer technology than CRT. LCD monitor use much less desk space and lightweight and use less electricity than CRT. They have been used for many years in the screen of laptops and notebook computers. They also work as touch screen in the tablets, mobile phones, and other handheld devices. The next type of computer display we will be discussing is LED monitor display, which is also known as light emitting diode. Here it uses light emitting diodes for backlight. The first LED monitor used cold cathode fluorescent lamps instead of LED lights as a backlighting to illuminate the screens. So here in the diagram you can see this bigger size of display or system is the CRT monitor, whereas the thinner monitors are known as LCD and LED monitor. Now we will be discussing about the working principle of the three displays. First, let us start with the CRT monitor. So we already know something about CRT monitor, that it is the display screen which produces images in form of video signals. It is a type of vacuum tube which displays images when the electron beam through the electron gun strikes on the phosphorus screen or the CRT monitor. The electron gun emits three colors of red, blue and green, which can produce any color form out of it to produce a required image. In other words, the CRT generates the beam, accelerates it at a very high speed and deflects it for creating an image on the phosphorus screen so that the beam becomes visible or the image becomes visible. So let's see about the working of CRT with the CRT diagram. So here let's first discuss the diagram, and according to this we will be discussing the working principle. So here we have two pins and there is one base. The cathode with a heater is present there. There is a grid. There are pre-accelerating anode, focusing anode and accelerating anode. This three basically is used for the direction of the beams. And next we have a vertical deflection plate and a horizontal deflection plate so that the beam can be directed to any position of the screen. There is a coating, and finally there is a phosphorus screen. So the working of CRT depends on the movement of electron beam. The electron gun generates sharply focused electrons which are accelerated at high voltage. This high voltage electron beam, when strikes on the phosphorus screen or the fluorescent screen, it creates luminous number of spots which meanwhile creates the images on the screen or the monitor. So the cathode heats up with the heater and the electron gun from which the cathode heat ups the electron gun from which the electron emits. The grid, these electrons are nothing but the red, green and blue electrons. The grid is the small metal hole which helps the electrons to avoid deflection so that the electrons move forward straight. The pre-accelerating anode, focusing anode and accelerating anode are basically used to keep the straight path of the electron. So this three provides path to the electron, or we can say straight path to the electrons. After exiting from the electron gun, the beam passes through the pair of electrostatic deflection plate which is known as horizontal and vertical deflection plates or direction plates. These plates deflected These plates deflect the beams when the voltage is applied across it. The one pair of plate moves the beam upward and the second pair of plate moves the beam from one side to another. So one plate moves it from upward downward position and other in horizontal position from one side to another. The horizontal and vertical movement of electrons are independent of each other, and hence the electron beams positioned anywhere can position anywhere on the screen. The working parts of a CRT are enclosed in vacuum glass envelope so that the emitted electrons can easily move from one end of the tube to other. Next, we will be discussing about the LCD display. The LCD display technology works by the blocking light technology. Specifically, an LCD is made up of two pieces of polarized glasses that contain a liquid crystal material between them. The backlight creates light that passes through the first substrate. At the same time, the electrical currents causes the light crystal molecules to allow varying levels of light to pass through to the second substrate and create the colors and images that we basically see. So let's first know why LCD is used over CRT. The first point is the LCDs are smaller in size. LCD occupy approximately 60% less space than the CRT displays, which is a very important feature when there is very limited space in the office. Other than that, the second advantage point is lower power consumption. The LCDs typically consume about half of the power and emit much less heat than the CRT displays. Next point is lighter weight. The LCDs weigh approximately 70% less than the CRT displays of comparable size. The fourth point is no electromagnetic field is used in LCD. The LCD do not emit electromagnetic fields which are not susceptible to them. Thus, they are suitable for use in areas where CRT cannot be used. And finally, there is longer life. LCD have a longer useful life, or it is more reliable than the CRTs. Let's see the working principle. The liquid crystal are the liquid chemicals in a state that has properties between those conventional liquid and solid crystals. That is, a liquid crystal may flow like a liquid, but its molecules may be oriented in a crystal-like way. The liquid crystal molecules can be aligned precisely when subjected to an electric field, as in the way metal shavings line up in the field of a magnet. When properly aligned, the liquid crystal allow light to pass through. The liquid is normally transparent, but if it is subjected to a strong electric field, ions move through it and disrupt the well-ordered crystal structure, causing the liquid to polarize and hence turn opaque. The removal of the applied field allows the crystal structure to reform and the materials regain its transparency. So here is the liquid crystal on and off state, in which the crystal molecules or the liquid crystals are already in tilted form when there is no voltage provided. Okay, so after crossing from the vertical polarization, it can move and cross through the horizontal polarization too. But in the on state, the crystal molecules are aligned straight so that the light cannot pass and we are not able to see the image. So in the next video, we will learn much about the LCD. This much for this slide. Thank you.